Let's see why we say that a pure crystalline polymer does not have Tg and it has only melting point. See, a polymer which is capable of exhibiting long range order, that is, if it is perfectly arranged, the molecular segments are perfectly arranged, then it is called a crystalline polymer. At low temperatures, what happens is this molecular, since they are in perfect order, there will be force of interaction, strong force of attraction, and the molecular mobility is arrested, and it will exist in the crystalline solid state. And why they are firmly held in the crystalline state? Because of the strong intermolecular forces. But it is so strong that the energy that is required to overcome such forces forming the crystal is very high, and that can be overcome only by giving very high temperature. But what happens at high temperature is never pass from the solid state to the rubbery state and does not possess the glass transition. But when at sufficiently high temperature, what happens is molecular mobility will set in abruptly, and this long range order is lost, and now the polymer will start flowing directly to the source. It will move from the solid state to the liquid state directly, and the temperature at which this transition takes place is called the melting temperature. So in a pure crystalline polymer, since it is forming crystallites and there is high energy has to be supplied to overcome these crystallites, it is never undergoing a TG or a transition from glassy state to rubbery state, but it is directly undergoing a change from the solid state to the liquid state. But a crystalline polymer can made to exist in the glassy state by melting it. We know that by melting it will be in the liquid state, and it has to be cooled very abruptly. That is, we call it as quenching, without giving any time to orient the molecules to form the crystallites. And most of the polymers which we use in practically are neither fully crystalline nor fully amorphous. They are semi-crystalline. That is, it will have some parts where there is perfect order, and it will be having also irregular arranged segments also. So it is having crystalline nature and the amorphous nature. So partially crystalline polymers possess both the glass transition temperature and also the melting temperature. So below Tg, what happens is these amorphous regions which have no perfect order, they will move on to the glassy state, but the crystalline regions will remain in the crystalline state itself. At Tg, what happens? At Tg, these amorphous regions will move on to the rubbery state. Then also the crystalline regions will continue to be in the crystalline state. But at melting temperature, these crystalline regions will melt and pass on to the liquid state. Okay, so beyond the melting temperature, amorphous region and the crystalline region become one, and the polymer will be whole, as a whole will be in the liquid state. Beyond the melting temperature, what happens? The whole polymer will melt, and both will be the region, amorphous region and the crystalline region will be in the liquid state.